So section 2.4 is all about simplifying fractions. Let's take fractions that mean the same thing and let's put them in the simplest form. So if you had an ice cream cake, because I'm tired of pies and pizzas, and we divided that cake into 3 pieces, 2/3 would be represented in this first ice cream cake right here, right? We have 2 out of 3 of the pieces. Well, what if we had cut that ice cream cake into 6 equal pieces and we had taken 4 of them? Then we would have 4/6 of that cake, ice cream cake. And look, they actually are the same amount of cake. Let's take it a step further and cut them into, so we're going to cut this cake into 9 equal pieces and take 6 of those pieces. And once again, see how all of those represent the same amount of stuff. Each of those fractions is what we would call equivalent. They're all meaning the same thing. They represent the same amount of stuff. And so we call them equivalent fractions. Okay, and so what we're going to do in this section, first of all, we're going to show you a couple of methods of testing if something is an equivalent fraction. And then we're going to show you how to simplify your fractions. Because if you have a fraction, if you end up with something like 6/9, the best way to state that fraction is in its most simplified form, which would be 2/3. So let's start by thinking more about equivalent fractions and how to test if something is equivalent. So if you want to know if 2 fractions are equivalent, okay, so I'm just going to write an equal sign here with a question mark to say we're checking if those 2 things are equal. One method to find out is to draw an X. Okay, if this first line, A times D, equals the second line, C times B or B times C, then they are equivalent. So let's do an example. So in A here, we're trying to decide if 3/8 means the same thing as 9/24. So what we're going to do is draw ourselves an X, and we're going to say 24 times 3. And we're going to ask ourselves, does that equal 8 times 9? So go ahead and get out your calculator here. And so we have 24 times 3. And that gives me 72. And so we want to know, does that equal 8 times 9? Well, 8 times 9 is also 72. So yes, these 2 are equivalent. Let's do the next one. So we're going to ask ourselves this time, does 9 times 7, is that equal to 8 times 8? And so 9 times 7 gives us 63. And 8 times 8 gives us 64. So no, not equivalent. This one here is yes. All right, go ahead and pause the video and try that next one. Okay, so hopefully you had a chance to try this one on your own. So we have 16 times 3. And we're asking, does that equal 12 times 4? 16 times 3 gives me 48. Okay, and 12 times 4 also gives me 48. So yes, these 2 fractions then are equivalent. Okay, there's a second method that we can use, and that is you can ask yourself if you had to multiply the numerator and the denominator by the same amount. So for example, in this first case here, to get from the 6 to the 12, what would we have to multiply by? Here we'd have to multiply by 2. What about the bottom? Well, 7 times 3 gives us 21. So we didn't multiply by the same amount, so no, they're not equivalent. Okay, next one then, 4 times what would give us 80? Okay, so that would be 20. 5 times what would give us 100? Also 20. So because those 2 were the same numbers, yes, they are equivalent. Go ahead and try that last one on your own. Click pause. Okay, and for this last one, to get from 1 to 3, we had to multiply by 3. To get from 12 to 12, we just had to multiply by 1. So no, they're not equivalent. And if we think about that one, if we had an ice cream cake and we divided it into 12 pieces, 1/12 would represent one of those pieces. 3/12 would represent 3 of those pieces. So no, they don't mean the same amount of stuff.